Today we are learning about ratios. Please copy down the standard Benchmark indicator on a clean page in your math notebook. The student will describe and compare two sets of data using ratios and will use appropriate notation such as A to B as a fraction, A to B in words, or A to B using the colon. Understanding ratios. A ratio is a pair of numbers that compares two quantities. Count to find the ratio of squares to circles. So in our group over here to the right, we can see we have 4 squares to 3 circles. So the ratio 4 to 3 can also be written 4:3 or 4/3 as a fraction. The order of the numbers in a ratio is really important. 4 to 3 is the number of ratios of squares to circles. 3 to 4 is the number for the ratio of circles to squares. So it does make a difference what order the numbers are in. We're going to use the picture above for exercises 1 through 6. Write a ratio for each comparison in 3 ways. So for number 1, we want to compare the number of triangles to the total number of shapes. And we can see we have 1 triangle and there are 8 shapes total. When they're talking about the total number, that does include all of the shapes, so the triangle's included in that. So we're going to write it in the other 2 ways, with the colon and as a fraction. And ratios, just like fractions, should always be put in their simplest form. This one is as simplified as it can get. For number 2, we're looking at the number of squares to the number of triangles. So if we look at our picture here, we can see that we have 4 squares, so that's for our first one, and 1 triangle. So our ratio is 4 to 1. We're going to write it in all 3 ways. And with ratios, it's okay to have an improper fraction. It just depends on what the ratio is asking you to do. In this case, it's 4 to 1, so the 4 goes on top and the 1 goes on the bottom. For 3, we have the number of triangles to the number of squares. So in this case, we're reversing the ratio we just did above. So we know there's 1 triangle and 4 squares, so we're going to write it in all 3 ways. For 4, we have the number of triangles to the number of circles. So we know there's 1 triangle, and we know there's 3 circles. So our ratio is 1 to 3. For 5, we're going to do the number of circles to the total number of shapes. We know we have 3 circles, and there are 8 shapes. So our ratio is 3 to 8. For 6, we have the total number of shapes to the number of squares. So in this case, we know we have 8 shapes to 4 squares. However, we know that ratios, just like fractions, need to be simplified. So in this case, we can divide both sides of the ratio by 4, so our actual ratio ends up being 2 to 1. For number 7, there are 14 boys and 16 girls in Mr. Allen's class. What is the ratio of girls to the total number of students in the class? Write the ratio 3 ways. So we know there are 16 girls, and we know if we add all the students together, we get 30 students. So first we're going to write the ratio as is, and then we're going to simplify. So our ratio starts out as 16 to 30. But now we need to simplify. So we're going to divide both sides by 2, and we get a ratio of 8 to 15. And again, we're going to write it in all 3 ratios. All right, for number 8, we're writing to explain. At a cat and dog hospital, 9 of the patients were cats, 17 were dogs. Use this fact to write two ratios. Explain what each ratio means. So if we look at the first one, we can compare the number of cats to dogs, so we know there's a ratio of 9 to 17. For our second ratio, we're going to do dogs to the total number of pets. So we know we have 17 dogs. If we add the 9 cat patients, we have 26 total patients. So we're going to do 17 to 26. Patterns in ratio tables. Two ratios that give the same comparison are called equal ratios. For example, 1/3 and 2/6 are equal ratios. Equal ratios can be thought of as equivalent fractions. You can use what you know about fractions to help find equal ratios. You can multiply or divide the numerator and denominator of a fraction by the same number to find equal ratios. So in our example here, they have 1/3. They multiply the numerator and the denominator by 3 to get 3/9. We know 1/3 and 3/9 are equal ratios. And the second one, they showed how you can use division. If you start with 3/9 and you divide the numerator and the denominator by 3, because whatever you do at the top of a fraction, you have to do the bottom, that divides and you get 1/3, and that's still an equal ratio. You can also use a ratio table to find equal ratios. And you can see each of the ratios: 1 to 3, 2 to 6, 3 to 9, 4 to 12, 7 to 21, and 10 to 30. Every one of those ratios simplifies down to 1/3, 1 to 3. So you always have to make sure as you're filling in your ratio table that whatever ratio you put in there simplifies down to the original ratio, the simplest fraction. So which pairs of ratios are equal? And if we look through, we know A is not equal because 2 times 2 is 4, but they multiplied the 3 by 6. So we're going to cross that one out. For B, we have 3/5 and 6/10, and if we look, they multiplied the numerator and the denominator by 2, making that a set of equal ratios. So we're going to circle that. Then we're going to look at C. We have 2/4 and 1/2, and those are equivalent because we know 2 divided by 2 is 1 and 4 divided by 2 is 2. And then we're going to look at D. We have 3/8 to 9/16. They multiply the numerator by 3, but the denominator only by 2. So that is not an equal ratio. So we're going to cross that one out as well. For number 2 and 3, they want us to complete the fractions to make equal ratios. So for 2/5, they want us to go to 4 something. So first we have to figure out what they multiplied the top by. So 2 times 2 is 4, so we're going to multiply the denominator by 2 as well. So 5 times 2 is 10. Then for the third one, we always look back at the original fraction. So when we go from 5 to 15, we multiply by 3. So we're going to do the same thing to 2. 2 times 3 is 6. For number 3, we have 8/28 going to 4 something. So to get from 8 to 4, we divide it by 2. So we're going to divide 28 by 2, which gets us 14. Then for the third part of this one, we have 28 going to 7, and we have to do something to 8. So 28 divided by 4 equals 7. 8 divided by 4 equals 2. So for 4 and 5, we're looking at the same ratio as we just looked at in 2 and 3, but this time we're filling them in on a table rather than the equal signs and the long line there. So 2/5 we know is equal to 4/10 and 6/15. For number 5, we have 8/28. We know that becomes 4/14 and 2/7. Please make sure you have all the work copied down in your math notebook and glue these papers in as well.